Saturn has been photographed more times than almost any other object in the solar system. It appears in textbooks, on classroom walls, on the covers of science magazines. The image is familiar to the point of feeling permanent. A pale golden planet wrapped in a wide, bright disk of ice and rock suspended in the dark. Peaceful, eternal, fixed. That image is wrong. Not wrong in the way that early maps were wrong. Missing details, waiting to be filled in. Wrong in a more specific and more troubling sense. The rings that define Saturn, the ones that make it the most visually distinctive planet in this solar system, are disappearing. They have been disappearing for a long time. And the James Webb Space Telescope, the most powerful observatory humanity has ever built, has been adding new layers to that picture. What it keeps finding does not make things look better. The story starts with what we thought we knew. For most of modern astronomy, the assumption was that Saturn's rings were ancient, formed early in the solar system's history, roughly 5 billion years ago, and stable ever since. That assumption was reasonable. The rings are enormous. The main ring system spans approximately 280,000 Darwin kilometers from edge to edge. The particles that make them up range from microscopic ice grains to chunks the size of houses. Something that massive, that wide, that visually dominant. It seemed like something that had always been there and would always be there. Then Cassini arrived. The Cassini spacecraft reached Saturn in 2004 and spent 13 years in orbit, collecting data that no flyby mission could have produced. When Cassini made its final close passes between the rings and the planet in 2017, the sequence mission scientists called the grand finale, it measured the mass of the rings directly for the first time. The result, published in 2019, was not what anyone expected. The rings were far less massive than previous estimates had suggested, and from that mass, researchers could work backward to calculate age. The conclusion: Saturn's rings are almost certainly less than 100 million years old, possibly as young as 10 million years. On the scale of the solar system, that is not ancient, that is recent, staggeringly recent. The dinosaurs were already walking on Earth, under the best current estimates, before those rings existed in anything close to their current form. That single finding changed the entire framing of the question. If the rings are young, they had an origin, a specific event or series of events that created them. The leading hypothesis is that one or more of Saturn's moons was pulled apart by tidal forces or collided with another body, and the debris spread into orbit. Another possibility involves a large comet or icy object that wandered too close and was gravitationally torn apart. Either way, the rings are not a permanent feature of Saturn. They are a phase, a temporary structure in the middle of its own slow dissolution. And that dissolution is measurable. This is where ring rain enters the picture. Ring rain is not a metaphor. It is a confirmed physical process, observed and quantified by Cassini. Charged particles from the rings, primarily water ice ionized by ultraviolet light and plasma interactions, follow Saturn's magnetic field lines down into the upper atmosphere. The planet is consuming its own rings. Cassini's instruments measured the rate of this inflow during the grand finale, and the numbers were striking. Saturn is losing ring material at a rate equivalent to filling an Olympic swimming pool roughly every 30 minutes. Under the most aggressive models, the rings could be substantially gone within 100 million years. Under milder estimates, perhaps a few hundred million. Either way, on an astronomical timescale, the end is not distant. But ring rain is only part of what is happening. Saturn has a population of small inner moons, Prometheus, Pandora, Atlas, Pan, Daphnis, that orbit within or just adjacent to the ring system. These are not incidental. They are gravitationally active, and they reshape the rings in real time. Prometheus and Pandora orbit on either side of the narrow F ring and act as shepherds. Their gravitational pulls keep the ring material from spreading outward or inward, maintaining the ring's defined edge. But the interaction is not passive. Each time Prometheus swings close to the F ring on its slightly elliptical orbit, it pulls streamers of particles outward, creating repeated wave-like distortions. Cassini captured these events in detail. The moon does not destroy the ring, but it continuously deforms it, redistributes material, and in some models contributes to slow net mass loss over time. Daphnis does something even more dramatic. This small moon, only about 8 kilometers across, orbits inside the Keeler Gap, a 42-kilometer wide division in the A ring that it has carved out through its own gravity. As it moves through that gap, it raises waves in the ring edges that can tower up to 5 kilometers above the ring plane. The ring is not passive material sitting in a flat disk. It is a dynamic medium, constantly being pushed, pulled, and sculpted by the moons embedded within it. This is the physical reality that the phrase shredding the rings is gesturing at, crudely, but not without a basis in what the data actually shows. Now consider what JWST brings to this picture. In June 2023, the James Webb Space Telescope turned its mirror towards Saturn. The resulting infrared images were immediately striking. but for a reason that surprised even researchers. In JWST's infrared view, Saturn's atmosphere appeared unexpectedly dark, darker than the rings themselves. That is the inverse of what optical telescopes show. The reason: JWST captures wavelengths that reveal methane absorption in Saturn's atmosphere, producing a contrast that no previous space telescope had imaged with this level of clarity. The rings, composed primarily of water ice, reflected infrared light in ways that stood out sharply against the methane-heavy atmosphere below. It was a new way of seeing a familiar object, and it exposed atmospheric dynamics that scientists are still working to fully interpret. Beyond the atmospheric imaging, JWST's infrared sensitivity allows researchers to study ring particle composition with spectral detail that Cassini's instruments could not fully match. Water ice signatures, trace organics, the distribution of particle sizes across different ring regions. All of this is being refined using JWST data in ways that sharpen the models of how the rings are losing mass and where the material ultimately goes. What JWST did not observe, to be precise, is a single dramatic moment of a moon tearing the rings apart in real time. That process is not that fast. It plays out over millions of years. No telescope captures that in a single observation. What JWST provides is a new layer of measurement, a more detailed chemical and thermal portrait of a system already known to be in slow, measurable decline. Each new observation adds resolution to a story that was already in motion before the telescope existed. And that story, assembled piece by piece, leads to a realization that is harder to dismiss the more closely you look at it. We happen to exist at the precise window in time when Saturn's ring system is near its peak. A few 100 million years earlier, the rings may not have existed in anything close to their current form. A few 100 million years from now, based on current measurements, they may be substantially gone. The humans who first pointed a telescope at Saturn 400 years ago were already inside that window, and so are we. Here is the question that this raises, and it is worth pausing on before going further. Knowing that Saturn's rings are almost certainly temporary, that they are being actively consumed and reshaped right now, does that make the image of Saturn more beautiful to you, or more unsettling? A structure this iconic, this photographed, this embedded in how we picture the solar system, and it has an expiration date. Drop your answer in the comments. Because what people feel when they sit with that fact tends to split in a very specific way, and it matters for what comes next. The current models are coherent. Ring rain is measured, shepherd moon dynamics are documented, mass loss rates are calculated from real data. The picture they paint is internally consistent. A young ring system in predictable decline, shaped and accelerated by the same gravitational forces that formed it. That is the mainstream interpretation, and it carries strong evidential support. But the models have gaps. The exact mechanism that formed the rings remains debated. The role of small, poorly characterized inner moons in driving localized mass loss is not fully resolved. JWST data on ring composition is still being actively analyzed, and early results have already prompted revisions to prior spectral models. Some researchers have proposed that the ring system may not be losing mass at a uniform rate, that there are periods of accelerated loss driven by resonance events or gravitational encounters that could compress the remaining timeline significantly. Others argue that the loss rate measured during the Cassini grand finale may not represent a long-term average. The debate is not whether the rings are declining. It is how fast, and whether we are witnessing an ordinary phase or an accelerating one. That distinction changes everything about the timeline. If the conservative models hold, the rings persist for hundreds of millions of years, fading gradually. If the more aggressive estimates prove correct, if JWST's data, once fully processed, identifies faster loss mechanisms or previously undetected dynamics, the window is shorter than current projections suggest. Not shorter on a human scale, but shorter in a way that means the certainty we feel about Saturn's appearance is built on a measurement, not a constant. Either way, this is a structure with an expiration date. Every image ever taken of Saturn, by Voyager, by Hubble, by Cassini, by Webb, was captured during a narrow interval of cosmic time in which those rings happen to exist. The window closes. The rings do not regenerate. When the material is gone, pulled into the atmosphere, scattered by resonances, dragged along magnetic field lines until nothing remains, it does not come back. Saturn will still be there. It will still be a gas giant, massive and banded and cold, completing its orbit every 29 years as it always has. But the structure that makes it recognizable, the feature that separates it from every other planet in the solar system's catalog, will be absent. A plain sphere where the most geometrically precise gravitational sculpture in our solar neighborhood once existed. What JWST is doing is not announcing a catastrophe on any timescale that touches human life. It is adding precision to a process that was already running before the first human looked up at the night sky. The rings are young. The loss is real. The moons are active. The measurements are getting sharper. And what the data continues to reveal, observation by observation, is that the thing most people think of when they picture Saturn is not a permanent fixture of the universe. It is a moment. We are living inside it. If that kind of story, the solar system's hidden countdowns, the things changing faster than we assumed, the structures that look permanent and aren't, is what you want more of, subscribe. There are more of them. And the next one starts where this one leaves off.